Hello students, today we will learn about hexadecimal system used in computer, and we will also learn about its various interconversions. Means in this lecture we are going to learn about the introduction part, and then we will learn how to convert decimal numbers into hexadecimals, and we will learn for both, means whole decimal numbers as well as fractional decimal. Similarly, hexadecimal to decimal conversion we will learn, then hexadecimal to binary conversion, and binary to hexadecimal. Okay, so directly coming to the topic without wasting time. See, in hexadecimal system, total 16 unique digits are used for representation of a number. Means for decimal system, there are 10 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. In hexadecimal system, there are total 16 digits used to represent a number. Those are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But for 10, there is a symbol. You will not use the number 10, that is A. So A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. Okay. So for 10 to 15, these symbols are used, and rest of the digits are numerals. Okay. Now, why hexadecimal system is used? See, the conversion of hexadecimal to binary number system is an easy and one-step process. Okay. So by one step only, we can convert hexadecimal to binary. So we require fewer number of components when we want to convert the binary system into hexadecimal, or the hexadecimal system to binary system. This is the one of the reason that it is used in computers. And similarly, the hexadecimal codes requires less space compared to that of binary or decimal. They requires less amount of memory. This is also one of the reason that it is widely used in computer systems. Now, suppose this is the decimal number. By example, we will learn directly by the example. That is 11235 decimal. We want to convert it into hexadecimal. Now, what you have to do is divide 11235 by the help of 16. You will get some question and some remainder. So write the question just below this number 11235. This is the question, and remainder aside of it. Because remainder over here is 3 and question is 702. Okay. Now take this 702 again divide by 16. You will get some question and some remainder. Okay. So below this 702, write the question, that is 43, and write the remainder, that is 14. So for 14, we are using the symbol E. Okay. So we will take this symbol E. Okay. Now this 43 again divide by 16. You will get some question, that is 2. Okay. And some remainder, that is 11. Okay. Now 11, the symbol is actually B. A is 10, B is 11. Okay. So like this. Okay. Now you have to continue this process up to the time you are getting a quotient which is less than 16. That's it. Once you are getting a quotient which is less than 16, over here 2 is less than 16. Now you have to stop. Now, as I have shown by the help of this arrow, in that order you have to write the number. Means 2, then B, then E, then 3. Okay. So 11235 decimal is equals to 2BE3 hexadecimal. That's it. Okay. One more example. Suppose the number is 7860. Okay. Now divided by 16, you will get some question. Like this, you have to divide. You will get some question, that is 491, remainder right aside of it. Now 491 divided by 16, you will get 30 as question and 11 as remainder. For 11, hexadecimal symbol is B. Okay. Now similarly 30 divided by 16, you will get 1 as question and 14 as remainder. For 14, hexadecimal symbol is E. Now 1 is smaller than 16. I told you that you have to repeat this process up to the time you are getting a number less than 16. That is 1. The question is less than 16 over here. So as like that of this arrow, in this direction you have to write the number 1 EB4. So 1 EB416. So this is decimal, this is hexadecimal of 7860. Similarly, 860 is there. This is decimal. You want to convert it into hexadecimal. Divided by 16. This is the question. And this remainder you will get. For this 12, the symbol is C. Hexadecimal symbol is C. Similarly, 53 divided by 16, you will get 3 as question, 5 as remainder. Now 3, you have got a number. A question which is less than 16, you have to stop over here. Now 3, 5, C. So this is the hexadecimal conversion of this decimal number. Now, in case it is a fractional number, you want to convert a fractional decimal number into hexadecimal. What you have to do? Suppose the number is 2234.56. This is decimal. You want to convert it to hexadecimal. Now, to the number which is toward the left hand side of this point, you have to go as like this, means this exercise you have to do to find the hexadecimal of 2234. Okay, so that is 8 ba 16, so 8 ba 16, that's it. Now for the number which is right hand side of this point, how you have to do, this is 0.56. Okay, multiply 0.56 with 16, you will get 8.96. Okay, now this 8 will be used for hexadecimal representation. Now this 0.96 into 16, you will get 15.36. Now this 15 stands for F. Hexadecimal symbol is F. So this F will be used for hexadecimal representation. Similarly, for this 0.36 multiply with 16, you will get 5.76. This 5 will be used for hexadecimal representation. Now you can carry on this process, means even after this also 0.76 into 16 you can do, but it depends that after point how many digits you want to keep. Suppose I want to keep only 3 digits, so I can stop here. So the number will be for 2234, the hexadecimal is 8ba, so 8ba point 8f5, like this. So this is the hexadecimal representation of this number 2234.56. So you would have learnt about this. You can exercise some more examples by your own. Now hexadecimal to decimal conversion, means there is a hexadecimal number, you want to convert it into decimal number. How you can do, see, suppose the number is 4b67, b stands for what, it is actually 11. Okay, now how many, if you are counting from this right, how many digits are there, it is 1 2 3 4. Okay, now what you have to do, 4 into 16 raised to the power the number of that number 4 minus 1. So this 4 is at fourth place. So 4 minus 1, that is equal to 3. So 4 into 16 to 3. Plus, now this b stands for 11. So 11 into 16, the place number of this b is 3. Counting from 7, 1 to 3. So 3 minus 1 is 2. So 16 to the power 2. Plus 6 into 16 to the power 1. Because this the place number is 2. So 2 minus 1 is 1, and then again plus 7 into 16 to the power, the place number is 1, 1 minus 1 is 0, so 16 to the power 0. Now this 4 into 16 to the power 3 is 16384, and this 11 into 16 square is 2816, 6 into 16 is 96, and 7 into 16 to the power 0 is 7. Adding up all these, you are getting 19303. So this is the decimal representation of this hexadecimal number. One more example, 3EEAA16, you want to convert it into decimal. This is the hexadecimal number. Now counting from this rightmost digit toward left, so 1 2 3 4 fifth. So 3 is a fifth place, so 3 into 16 to the power fifth, 5 minus 1. Okay, so that is 4. Plus E stands for 14, we know this thing, hexadecimal number of E, uh, the decimal number of E is 14. So 14 into the place number of this E is 4. So 14 into 16 to the power 3, plus again this 14 into 16 to the power 2, because this is at third place. Now this A stands for 10. So 10 into this is a second place. So 10 into 16 to the power 2 minus 1, that is 1. And then again 10 into 16 to the power 0. So in case you are adding up all these numbers, ultimately you will get 257706. This is the decimal representation of this hexadecimal. Now, in case some hexadecimal number is there, but it is fractional, then how to convert it into decimal? Okay. Suppose the number is 2EA6.AB2 hexadecimal. You want to convert it into decimal. Now, what you have to do? You can see that from this point, these are the left hand side digits and these are the right hand side digits. So, for both the sides, you have to do separately. Okay, so how, for this 2EA16, if you are counting from this point, then 2 is at fourth place. So 2 into 16 to the power 3, 16 to the power 4 minus 1, that is equal to 3, plus E stands for 14. So 14 into this T is at third place. So 16 to the power 3 minus 1, that is equal to 2, plus A stands for 10, 10 into 16 to the power 1, because it is a second place, and 6 into 16 to the power 0, because it is a first place, counting from this point. Now, as you are moving toward right hand side, then you have to use negative powers. For example, this A is actually 10. A is symbol of 10. So 10 into 16 to the power minus 1. This is at first place counted from this point. Okay. So 10 into 16 to the power minus 1. Plus this B stands for 11. 11 into, it is a second place. So 11 into 16 to the power minus 2. And third is 2. So 2 into 16 to the power minus 3, because it is a third place. Okay. Now, in case you are doing the calculations, ultimately you will get it is 11942.668. So this is the decimal representation of this fractional hexadecimal number. Similarly, there is one more example, 3CA6.EE16. Again, for this 3CA16, counting from this point, this 3 is at fourth place. So 3 into 16 to the power 4 minus 1, that is equal to 3. Plus C stands for 12. So 12 into this C is at third place from this point. So 12 into 16 to the power 3 minus 1, that is 2, plus a 10 into 16 to the power 1, plus 6 into 16 to the power 0. Now, to the right hand side of this point, there is EE16, and E is at first position from this point to our right hand side. So E stands for 14. So 14 into 16 to the power minus 1. Now, second E is at second place. Again, there is 14. So 14 into 16 to the power minus 2. Okay. Now, calculating, adding up all these numbers, you will get 15526.929. So this is the decimal representation of this hexadecimal number. Now we will learn that how to convert hexadecimal numbers into binary numbers. Okay. So for this thing, you have to keep remember the 4-bit binary form of the 16 hexadecimal unique digits. For example, if the number is 1, you know this thing that in hexadecimal number system 1 to F are the numerals which are used for number representation. So for 1, if we are taking it a decimal, then the binary representation in 4-bit form is this 1,000 before this one. So the value is same, just zeros are applied. So this is the 4-bit form of 1. Now 4-bit form of 2, decimal to binary 0010. Similarly for this 10, it is 1010 binary form, and this B stands for 11. For 11, it is 1011. So up to 15, these are the 4-bit form of 16 hexadecimal unique numerals. Okay. Now with example we will learn, suppose the hexadecimal number is 4B67. This is the hexadecimal, we want to convert it into binary. Now, just you have to write the 4-bit binary form of all these digits. That's it. This is how you can convert. For example, this 4. So 4 is equivalent to 0100 binary. So that I have written for this 40100. For this B, what is the 4-bit binary form? 1011. So I have written 1011. For 6, the 4-bit binary form is 0110. So I have written 010, and for 7 it is 0111. So written. So that's all. This is the binary conversion of this hexadecimal number. Similarly, 3EEAA16. So for 3, the 4-bit representation is 0011. So that I have written. For E, it is 1110. So 1110. Again E, again 1110. And for A, it is 1010. So 1010. And again A, so 1010 more. So this is the binary representation of this hexadecimal number. Now, in case it is a fractional hexadecimal number, then how to proceed? See, suppose the number is 3CA6.EE. Okay, this is the hexadecimal number. We want to convert into binary number. So, again, for this 3, it is 0011, return C, it is 1100, so 1100 return A, it is 1010, return, and then 6. So for 6 it is 0110, so that also return point. Just for E also you have to do the same. For this E, for E it is 1110 return, again E 1110 return. That's it. This is the conversion of this hexadecimal into binary. Similarly, for this 2EA6.AB2, so for 2 it is 0010 return. Similarly for E I have written, A I have written, and 6 I have written. Point for this A, whatever the binary representation, that is 1010. So return, and then B return, and then for 2 also return. That's all. This is the conversion of this hexadecimal into binary. Now, in case you want to convert a binary number into hexadecimal, then how you can do? Simple. First, you have to count the number of digits in the binary number. Suppose this is the binary number you want to convert into hexadecimal. So total digits are 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 digits are there. Okay. So this counting must be a multiple of 4. So this is 9. It is not a multiple of 4. So you have to add some more zeros toward the left, minimum number of zeros toward the left, so that it will become a multiple of 4. For example, in case I am adding three zeros to this number to the left hand side, the value will remain same. However, the counting will be in the multiple of 4. So I have applied those three. So this was the original number, applied three more zeros. Now there are 12 bits. 12 digits are there. 12 is actually multiple of 4. Okay. Now consider the quadruplets. Okay. For example, this is one set, 0001, and then 1110. So 1011. So for double 0001, the number is 1 written. For 1110, the number is E. So written, and 1011 B. Okay, so that also I have written. That's it. So this is the conversion of this binary into hexadecimal. Similarly, one more number, 10101. Again, the number of digits are 6. 1, 2, 3, 4, 5, 6. So it is not a multiple of 4. So we can add two minimum, we can add minimum two zeros toward the left hand side, so that the digits will be 8 and it will become multiple of 4. So I have applied those. So this number is equals to 00101101. Value remains the same, just zeros are applied. Now consider the set of 4. So 0010, this is one set, then 110 second set. So 0010 is the code of 2. So written, and 1101 is actually code of D. You can see. So written. So this is the hexadecimal representation of this binary number. Now, in case it is a fractional number, same job you have to do, but for left hand side, toward the left hand side of this point, uh, different job, and toward right hand side, different job. Now, toward the left hand side, how you have to do? See, suppose this is the number. Total number of digits are 1, 2, 3, 4, 5, 6, 7, 8, 9. Left hand side of this point, there are 9 digits. Okay, it is not a multiple of 4, so you have to apply 3 more zeros to make it 12 digit number. Left hand side of this point, 12 digits number, so it will become a multiple of 4. So I have applied. Now for this right hand side of this point, there are 3 digits. Okay, so for this case, what you have to do, you have to make the counting to be multiple of 4, but 0 you have to apply at the end, right hand side, not at the beginning. Okay, so 101, if I am adding one more 0, it will become multiple of 4, because it will become a 4 digit number, so that is a multiple of 4. Now just consider the 4 digit sets. Okay, like this. So 0001 is one set, that stands for 1, and 0110, that stands for 6, and then 1111, that stands for F, and then after point 1010, that stands for A. So that's all. This is the conversion of this fractional binary number into hexadecimal number. One more example. The number is 1111001.11111. Okay, so total number of digits toward left hand side of this point, 1, 2, 3, 4, 5, 6, 7, 8. So it is a multiple of 4. So we don't have to add any more zeros. Now toward the right hand side, digits are 1, 2, 3, 4, 5. So 5 is not a multiple of 4. So we can add 3 more zeros toward right hand side. Okay, so it will become 8 digits number. So this will be a multiple of 4. The counting will be multiple of 4. Now consider the sets of 4 digits. So 1111 is one set, so that stands for F. 1001, that stands for 9 point. Again 111, that stands for F, and 1000 stands for 1. So this is the hexadecimal representation of this fractional binary number. So hope by this lecture you would have understood about the hexadecimal system and its various interconversion with another number systems. Thank you.